Hey guys, it's me, Mrs. Applegarth, and today we're going to go over Chapter 3, Section 3, Proving Lines Are Parallel. Okay, we have several properties that we are going to be talking about, and so I want to make sure you guys write them all down. The first one we're going to talk about is the corresponding angles converse. So we know that if lines are parallel, then their corresponding angles are congruent. Remember from our previous lessons that way back in chapter 2, the converse means that we're going to switch the hypothesis and the conclusion. So instead of saying if two lines are parallel, that is going to be right at the back. So we are going to say instead, if two lines are cut by a transversal so that corresponding angles are congruent. So we're starting with the angles being congruent. Then the lines are parallel. So let's look at what that's, I'm a visual learner. Anytime I can see what we're talking about, then I know I'm good to go. So if angle 1 is congruent to angle 5, then lines A and B are parallel. So we do have, so let me just remind you, parallel lines, when they're parallel, they get the little arrows on them. So now we can say, yeah. So if angle 1 is congruent to angle 5, we can say A and B have to be parallel. Alrighty, the next one. And if I'm going too fast, you guys, please make sure you pause this video, rewind it, whatever you got to do to get these notes down. Alternate interior angles converse. We know alternate interior angles are congruent. So the converse of them, so the regular one says, if lines are parallel, then alternate interior angles are congruent. We're going to start with the opposite. If two lines are cut by a transversal so that interior angles are congruent, then the lines are parallel. Let's take a peek in case you forgot what alternate interior angles are. Angles 4 and angle 6 are alternate interior angles. They're interior, so they're the hamburger meat. And then alternate means one's on the left and one's on the right-hand side. So we're going to actually prove this just for fun because we like to prove stuff. So we are given angles 4 is congruent to angle 6. Our goal is to get to L, line L is parallel to line M, where it says do a flow chart or two-column proof. We are going to go ahead and do the two-column proof. I'm a math teacher. I love me some, and I love putting things in tables. Flow charts, they're all right, and we'll see one later on. All right, so we are going to start with the given. So angle 4 is congruent to angle 6. You guys are writing this down. So we're given angle 4 is equal to angle 6, so that goes to number 1 in our statement. It is given, that's the reason we give. We look at angle 4, and once you guys see it, if you don't see it right away, it's okay, don't feel stressed. We look at the other angle they give us. Angle 2, chilling here. What is it about angle 4 and angle 2? Oh, they are vertical angles. Vertical angles are congruent. So we're going to say angle 4 is congruent to angle 2, and the reasoning is because they're vertical angles. Okay. And you guys just remember, we have only done really 3 types of related angles other than the parallel lines ones. We've done vertical angles, we've done supplementary or linear pair angles, and we've done complementary angles. And when we do the parallel lines, we're really only going to be like vertical angles, or we're going to be linear pair. So really, we only have a couple of things we can put in here. So don't stress about like just this being blank. There are really only a couple of options we can put in there. Okay, so think about this. 4 is congruent to 6. 2 is congruent to 4. We can cut out the middleman and say 2 is congruent to 6 because 4 right here is our middleman. And the property that cuts out our middleman is called transitive. Okay. So we have, of our angles, we've got corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent, and same side interior angles are supplementary. Those are the only parallel lines ones that we have. Okay, so angle 2 is congruent to angle 6. And so we can now say L is congruent to M because the corresponding angles converse. Because if corresponding angles are congruent, then the lines are parallel. Yay! Okay, and again, if I'm going too fast and you need to stop, rewind, pause, whatever you need to do, go ahead and do it. All right, so we're going to take our same side interiors definition, which will help us remember what same side interiors are. So this is in the meat and on the same side of the transversal. So let me put in my parallel lines. Hold on, it is locked in place. Okay. So if we have line A and line B, and angle 1 and angle 2 are same side interiors, we can go ahead and say if 2 lines are cut by a transversal, so that consecutive interior angles, remember that is another name for same side interior, are supplementary, then the lines are parallel. So let's write that in the math talk. If the measure of angle 1 plus the measure of angle 2 equals 180, then A is parallel to B. So if the sum of the 2 angles is 180, then our lines are parallel. And let's go ahead and put on the parallel. I don't think I did it on our other one too, so we'll put that on. So we can say lines are parallel. So once we prove it, let's go ahead and tap on those little parallel lines. Okay, let me bring all that back. Boop, 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 boop. Give me the lines. Let's go, lines. I'm going to go for more lines. We'll get this in. There it is. Okay. Last of our converse, so we have exterior angles converse. So if we have 2 lines and a transversal, alternate exterior angles are congruent. So we have that information. Then we can say that the lines are parallel. We're going to go ahead and prove that. Oops, I'll keep that up there for a minute. So go ahead and draw this figure. And today we're going to have 1, 3, 5, 6, and 7. We know that 1 and 7 are congruent. So that's the alternate exterior angles are congruent. And we're going to show you the proof of why we can, with confidence, say that L is going to be parallel to M. I want this whole statement. Okay, so let's go. I'll give you the statements, and we can write down the reasons together. Again, I picked the 2-column proof. You can tell where my comfort zone is, right? So angle 7 is congruent to angle 1. Sorry, I did that in a little dyslexic way. Angle 1 is congruent to angle 7. We know that is given. Angle 1 is congruent to angle 3, and angle 5 is congruent to angle 7. We know that because they are vertical angles. And look how clever this was, that we put both vertical angles on one line, so we didn't have to, like, you could double it up, but then why make more work for yourself? Okay, so we have, if we look at our little chart here, we have 5 and 7, 3 and 1. Those two are congruent and those two are congruent by vertical angles. We got some alternate interior angles chilling here. So 3 is congruent to angle 5. Because if 1 is congruent to 7 and 1 is congruent to 3, so we can say 5 is congruent to 7. So this is like a way long transitive property. So so if 1 is congruent to 3, 1 is also congruent to 7, and 5 is congruent to 7 by the transitive property, angle 3 is congruent to angle 5. So we can say L is parallel to M by the alternate interior angles theorem, which we proved back in the beginning of chapter 3. Okay, if this is your first time with proofs, I'm going to say do not stress. On our assessments, I'm going to be giving you guys one or the other, the statement or the reason, and usually you'll have a pool of choices, so you're not just shooting in the dark at this. All righty. Let's go. Alrighty, so the next one we're going to prove, and in only 3 simple steps, yay. So we're going to prove that AD is parallel to BC. And I know you, like, look carefully, the B's chilling right here. We know that 5 is congruent to 6, so I put that in green. 5 is congruent to 6. And 6 is congruent to 4, I put that in double blue. So you can see the relationships. Anytime they give you a relationship, I find it helpful if I put that on the diagram. So I gave a list of reasons chilling over here so that we can just pull from them and see, oh yeah, is that angle 5? Which angle is it? So we look, what should normally go in spot number 1? Oh yeah, that's whatever the given is. Okay, and then the reason for that is always going to be given. This is not 100% of the time, but most of the time. All right, we're going to say angle 5 is congruent to angle 4, and our choices are symmetric, reflexive, substitution, or transitive properties. So if 5 is congruent to 6 and 6 is congruent to 4, we can say 5 is congruent to 4 by the transitive property. All right, so we know 5 is congruent to 6, 6 is congruent to 4, and we're trying to prove AD, which is this line, is parallel to BC. So we're going to put that on the last step. We're going to say AD is congruent to BC because alternate interior angles converse. All right, so we are proving lines parallel using these properties. All right, let's look at them in terms of algebra. Find the value of x that makes J parallel to K. So we're looking at, we've got 2 lines, J and K. If they are parallel, then these corresponding angles are going to be congruent. If these angles are congruent, then we can set them equal to each other. So if x squared minus 4 equals 21, I'm going to add 4 to both sides. I am going to get x squared equals 25. I'm going to take the square root of both sides. Then I get x is equal to plus or minus 5. Because remember, -5 times -5 is also 25. So it could be either one of these answers. Boop. All right, the next one. If these j is parallel to k, so that would be, we'll say this guy and this guy, then so the corresponding and the alternate interior angles have to be equal to each other. So we have this angle here and this angle here. Alternate interior angles have to be congruent. And that's the interior, and it's on different sides. So if I have 2x plus 1 equals 3x minus 5, I always pick the smaller of the x's to go first, minus the 2x. So we get 1 equals x minus 5. And then we add 5 to both sides. We get x is equal to 6. And I'm not sure why I dropped the plus or minus here. Okay. All right, let's check this out. We are given that C is parallel to D, and that angle 1 is congruent to angle 3. I have put those on our drawing. We want to prove that lines A and B are parallel. So let's walk through. I filled this in for y'all because I knew you would know it. C is parallel to D and angle 1 is congruent to angle 3. That is given. Angle 2 is congruent to angle 1 because corresponding angles are congruent. Yeah. And then angle 2 is congruent to angle 3. So if 1 is congruent to 3 and 2 is congruent to 1, what's it called when we cut out that middleman? Boop. Transitive property. And then finally we can say, since 2 and 3 are congruent, we can say A is parallel to B because alternate interior angles converse. So when you are finishing with the line angles or with the lines parallel, you use the converse. And it's going to be, you guys, on a multiple choice test, if you have the choice between alternate interior angles and alternate interior angles converse, and you pick the wrong one, it makes a difference. All right, that ends the notes on 3-3.